Hello, welcome back to another video. In today's video, we are going over the formulas that is used in CT, as well as I will show you some examples of some math problems. So if you found this video to be helpful, please like, share, and subscribe. And if you do not know, for the CT registry, since I am registered through ARRT, I follow their content outline. If you have checked out my other CT registry videos, then you have seen this before. But just for someone who does not know about it, there will be a total of 165 questions on the CT registry. Um, Let me see if I can highlight it for you. Down here where it's at 165. Um, for today, we're focusing on image production, which will give you 50 questions. Procedures is the largest part of the test. And then you have patient care, 22 questions, safety, 22 questions. That is the least part of the test. Then you also have those 30 unscored pilot questions down there at the bottom. Do not miss that. But if you live in another country or somewhere, you can still use this information. It's universal. It can still help you pass your test. Shout out to Mel. She commented on one of my videos recently. Just let me know, hey, do you have any physics videos on the math problems? Like I was telling her at the time when I was making these videos, it was literally no one, watching it because of, just people trying to find it pretty much. So if you want more videos, could you just let me know in the comment box? But right now, I do have a lot of videos like practice test questions. I have review lessons. A lot of the physics videos that I have, you will find them at the bottom of my playlist that I will link to the end of the video, but they're not necessarily titled CT physics. They may be titled spatial resolution and contrast resolution, or they may be titled informatics. All of that still falls under image production. So just letting you know, but we'll get started with the video. All right, so you have your pixel. Your pixel is also known as a picture element. Make sure you know your differences between pixel, voxel, and matrix. Those three terms, sometimes it can get people confused. I'll say it again. Know the definition and the differences between pixel, voxel, and matrix. Your pixel also displays the CT image. It is arranged in the matrix as individual boxes. The formula for pixel dimension, you have D equals DFOV, parenthesis millimeter, divided by matrix size. So your DFOV stands for display field of view. Your common matrix sizes in CT is 256 by 256, 512 by 512, and 1024 by 1024. So just make sure you know your numbers for your common matrix sizes. All right, so to test your knowledge, and you can pause the video, you can rewind it as many times as you need to figure out these answers. So I'll test your knowledge on the pixel dimension. So the question is, what is the pixel dimension for a display field of view of 50 centimeters with a matrix size of 512. I'll give you a hint. Remember the formula for pixel dimension. So just let me know, or you go back and just memorize the formula, write it down, whatever you have to do. And then you can pause the video at this point. Once you have your formula and calculator, you can pause the video, fill it out, fill it in, and then I'm going to give you the answer right now so that it won't be like a long pause. So the answer. Okay, the answer is your formula for pixel dimension. You have to have that formula. You can write it down if you need to, or keep rewinding the video. But first, you need to change the 50 centimeters display field of view to 500 because we are converting this to millimeters. We're not using centimeters. The easiest way that I can change, or found out how to change from centimeters to millimeters, is just to add a 0 to the 50. So you want to also use your matrix size to determine this, which is 512. You do not use both of the 512s. You only use one. So that's all we're counting is one. So like I was saying, just put 512. So for your pixel dimension, you'll have D equals 500 millimeters divided by 512. That's when you'll have your calculator, and it will give you a pixel size equals 0.9766 millimeters. So I hope that makes sense. Just keep rewinding, pausing until you understand. Now we have our voxel. Your voxel is also known as volume element, the volume of tissue that is represented by a pixel that is in the matrix. It is used to display the CT image. So this is your formula for your voxel volume. And then also know that D equals pixel dimension, Z equals voxel depth, mm equals millimeters. So know your formula. Whenever you have numbers, just plug it in. Your CT number, this is given in Hounsfield units. The inventor is Sir Godfrey Hounsfield. I do have a full video in my playlist where I go over all of your CT numbers. Water is 0, CSF is 15 approximately. So I have those numbers on another video. I'll try to remember to link that video and my full playlist at the end of this video. Your linear attenuation coefficient, make sure you know that symbol right there is a value or number that is given to an object to determine how it attenuates an X-ray. And then here is the equation for linear attenuation coefficient. So just make sure that you know that equation. If you see after the formula, you'll see that dot, that's times K. So K, it'll be 1,000 for K. And then I have an example right here. So what is the CT number for the linear attenuation coefficient formula below? The tissue number for this example is 0.50. The water number for this example is 0.20. And then the hint is know your formula for linear attenuation coefficient. So do you know your formula? If you do know your formula, you can pause this video, start plugging it in, working it out on a sheet of paper, and then I'm going to give you the answer right now. So your CT number formula is this. You see it right here. And this you have your CT number. The numbers that we use for the tissue is 0.50. So T is tissue, and then minus 0.20. W is water. So we'll have your 0.50 minus 0.20, and then multiply that by 1,000. That's where your K number comes in at. So after you have done that, you have 0.50 minus 0.20. That's going to give you 0.30. And then you're going to divide it by 0.20. So after you do that, you're going to take 1.5, because once you do 0.30 divided by 0.20, that is going to give you 1.5. Multiply that by 1,000 and you'll get 1,500. So a CT number of 1,500 will indicate a dense structure such as bone or calcification. Like I was saying in the previous slide, review the CT Hounsfield number video that I have in my YouTube playlist if you do not know your CT Hounsfield numbers. If you are finding this video helpful, could you please like, share, and subscribe for more videos? Also, feel free to leave comments like the other lady did. She left a comment and was like, hey, I'm studying for this, but I don't see this. Could you make a video for it? Or, something like that. All right, gonna test your knowledge again. So what is the CT number for the linear attenuation coefficient formula below? The tissue number for this example is 0.19. 0.181. The water number for this example is 0.180. Like I was saying, do you remember the formula for a linear attenuation coefficient? This is where you have your formula written down, or you keep watching the video to see the formula. And then now I will work out the answer for you. Okay, for your answer, you see the CT number, and you are going to take your tissue number, which is 0.181, minus the water, which is 0.180. You're going to get your number from that formula, which is going to be 0.001. If you do see that dot and that K, that means times 1,000, but we're not there yet. So once you take your 0.001, divide that by 0.180, and it will give you 0.0056. You want to multiply that number by 1,000 because K is 1,000. That's what that means. So that is going to equal 5.6, but round it up to 6, and that number is the CT number that will indicate fluid. So the CT number for water is 0, and the CT number for your CSF is approximately 15. So that all of those numbers is in the CT Hounsfield number video that I have in my playlist that I will link at the end of this video. Now we have our noise standard deviation formula. Make sure that you know the symbol for standard deviation. Also, the formula is below, and then xi. So the I is going to be lower than the X. It's going to be a little bit smaller, but this program wouldn't let me do it like that. So the xi is the CT value. The X is the average. It could be at least 100. Your N is the total number of CT values that is within the region of interest. So that is what your N is. All right, so now we are going to talk about pitch. Pitch is the relationship between the speed of the patient's table movement through the CT gantry and the width of the X-ray beam. The formula for pitch is pitch equals table feet per rotation divided by session width. So now we are going to see how well you know how to complete your formulas. Put in the comment box if you are getting it. If you're not getting it, just keep rewinding the video until you understand it. So pitch for this question is, so what is pitch for a CT machine? The section width is 6.5, so that's the number I'm giving you in millimeters. The table feet per rotation for each gantry is 8 millimeters. So do you remember the formula for pitch? That's when you are going to rewind the video right now to get your formula, and then you'll plug the numbers in that formula. So now I'm going to give you the answer. We'll work it out together. So the formula is pitch equals table feet per rotation divided by section width. But to test your knowledge, just try to, figure it out, plug the numbers in before you come to this part. So the number I was telling you for table feet per rotation is 8 millimeters. You want to divide that by your section width, which the number is 6.5 millimeters. That is going to give you 1.23. So your pitch would be 1.23. So it would be that number at the bottom in the blue. Now we have our beam pitch, which is a different formula, similar but a little different. For your beam pitch is going to be table feet per rotation divided by total collimation. So your total collimation is going to be the number of sections, multiply that by section width. If it doesn't make sense, you're more than welcome to pause the video and just keep rewinding. All right, to test your knowledge, what is the beam pitch for a CT machine? The table feed number is 50.00 millimeters. Your total collimation equals the number of sessions, that is 32, and then it's going to be 1.25 millimeters for the width, or how wide it is. So know your formula for pitch or beam pitch before you work it out. So know the formula for beam pitch. All right, so the answer will be this. You have your beam pitch. I plugged in that 50.00 millimeters. And then, like I was saying, for your total collimation, we have that number 32. Multiply that by 1.25. So the total collimation is the number of sections, which will be 32. Multiply that by section width, 1.25. For your beam pitch, that is going to give you 50.00, which is the top number up there. Divide that by 40, because 32 times 1.25 is 40. So your answer would be 1.25. Okay, so now we have our effective mass formula. Your effective mass formula equals mass divided by pitch. So when you see the line, that's divided by, your effective mass is calculated for the mass value per slice that is acquired. The table speed controls the effective mass. So just remember, the table speed controls the effective mass. So to test your knowledge, what is the effective mass for a CT machine? The mass is 40. For this problem, the pitch is 2. So know your formula for effective mass. This is where you have looked at it, you know it, you probably have written it down, and just work out this problem. Pause the video. Now let's just say you know your answer. I'll give you the answer right now. All right, so you have your effective mass formula, which is mass over pitch. For your effective mass, the number that I gave you for mass is 40. For pitch is 2. So you'll take 40, divide that by 2. That's going to give you 20. All right, so that's it for this video. If you found it to be helpful, please like, share, and subscribe for more videos so that you do not miss any new videos from me. Also, check out the CT registry playlist that I have linked or for you to click on, as well as the video for the CT Hounsfield units. The best way I can say to remember this is just try your best to remember your formulas. Also, your math problems, like I was saying earlier in the video, I'm not sure what your test questions will consist of because it changes all the time. This person just wanted me to make the video, and then it's also in, our CT school program books for us to know as well. So, like I was saying, I don't know if this is something that you will be tested on or not, but it doesn't hurt to study. But anyway, thank you all for watching, and I will see you all in the next video. Bye.